Psyched?
I'm psyched.
I am. Okay then. Okay, well. So well rehearsed, I know. No, this is a very informal meetup, so we'll keep it informal. I'll keep my introduction very short. Actually, as I said, I'm a front-end developer, but I'm very interested in front-end functional programming, and bringing functional programming to the browser with a pure language like Elm is really exciting for me. And that's why it's super cool to have Jessica here tonight. She is well known maybe for her podcast, Greater Than Code. She works currently at Atomist as on development automation.
Yes.
Yeah. And you're actually on holidays at the moment, sort of, because you already spoke at 2 conferences in the past week. And actually, tonight you're here, and then I think in a couple of days you're going already to Joy of Coding.
I mean, what could be more fun on holiday than to come here, right?
Yeah, right. Yeah, I agree. I would do the same thing. Yeah, exactly. What else? I think, well, actually, let's go to the program, because tonight you will have a talk about Elm first. You don't mind the interruption. If anyone has a question, just go ahead. Then we'll have a short break, and then the second talk. And yeah, if there's anything else, just, well, you can recognize us by our t-shirts, so just ask us any questions. My colleagues love it when you ask them questions. So I will keep it at this, and yeah, give hands up for Jessica.
Thank you, Martin. Thank you for coming. Welcome to Adventures in Elm. It is a meetup, and there's not a time limit, so I would really appreciate if something's not clear, or if you'd like to drill into something, if you're like, whoa, wait, what is that? Please just speak up. Today, I'm excited to talk about Elm, because Elm is awesome. Elm, finally lets me, a back-end developer, do things in the browser, that I can actually see, and without fear, and without pain, and without spending 6 hours learning the latest JavaScript build tools and frameworks. So I'm Jessitron, and is this going to work? Maybe if I turn it on. There we go. And I work at Atomist. I'm totally a backend developer. I do mostly Scala and some Clojure, and now some TypeScript, and I've done Java and Ruby, and Elm is my only front-end language. How many people have written some Elm? Lots. Okay, so this is going to be really kind of basic for that, but I mean, if you write Elm at all, you probably love it, so it's so beautiful to see. So I learned about Elm, gosh, it's probably been 3 years now, at a wedding. At a wedding in St. Louis, I'm sitting next to Richard Feldman, who I used to work with. We used to share an office, and now he's out in San Francisco, and he works at No Red Ink with Evan, and he's writing a book about Elm. And Richard tells me about this language, and he's like, it's purely functional, and it makes GUIs that run in the browser. And I was like, seriously? How, because purely functional and UI development were totally strange. How could those be the same? Because I used to make Java Swing apps, and man, that was the worst. I mean, the best you could do was pub sub, but you had to specify everything that needed to change at a particular point, and then oh, you got to be on the event thread in order to make any change. It was awful. And I was astounded that we could do purely functional development in the browser. But now, as a backend functional developer, I wish I was working in languages as functional as Elm on the backend, because Scala doesn't come close. So Elm, by being even more functional than the backend languages that I work in, has actually taught me that some of the things I held sacred in programming are maybe only necessary because my languages aren't good enough. So things like encapsulation and modularity are loosened. They can be loosened in Elm, which is really strange and surprising. But Richard insists, no, you don't make components. And Evan, who designs the language, is like, please no components. And I'll talk about that a little bit at the end when I have an app to like point at. Because today I'm going to go all the way from Hello World through a kind of functional Elm app that's like almost even useful, almost. And in like 40 minutes. So it'll be fun. It'll be fun. First of all, one of the big reasons that Elm is able to make programming both more functional and simpler is its very single purpose. Elm is a language for writing programs that run in the browser, and that's it. And the focus then, Evan's focus in designing the language is about the development experience, is about making this pleasant. Not like race car driving fun, but like just more like biking in the Netherlands along a canal. It's smooth, and all the cars watch out for you. That's pretty sweet. Yeah, so the way Elm does this is that it does not compile to JavaScript. I mean, technically it does, but this is not a JavaScript transpiler. If you want to write code in another language that you can call JavaScript from, and JavaScript can call your code, Elm is not it. You want that, go to ClojureScript, go to Scala.js, go to PureScript. Elm is not it. Elm is very restricted. The fact that it compiles to JavaScript is an implementation detail. When WebAssembly is a thing, it will compile to that. So when I write my Elm code, which deals only in data, it accepts data in, and every function is exactly one expression, and it returns data out, and that's all it can do. The JavaScript that my Elm code compiles into is only useful within the Elm runtime. So the Elm runtime, which itself is in JavaScript, it does all the interactions with the browser and with the DOM, which is like, oh, document object model, that's right. That's the stuff that the browser uses. Can you tell I'm not a front-end developer? That's the thing that the browser says what it should display. And like React was developed in parallel with Elm, so they both have this idea of the virtual DOM of you tell me what you want the DOM to look like, and I will make it look like that very efficiently, and then you don't have to tell me update this, update that, update that. Just say, it should look like this now, and I'll be like, oh, it looks almost like that, and tweak it. Okay, so Elm does that. It's a different implementation from React. Some people say it's faster. I haven't heard anybody say it's slower, so maybe they're right. Yeah, and then the person interacts with the browser, and then that comes back to my Elm program as data. I can't make any statements. I can't instruct the browser to do anything except by passing a command, which is data, to the Elm runtime. So there's very strict boundaries between Elm code and JavaScript code. You can totally write interop, but it's not fast. Elm isn't about maximum speed. It's about safety, which smooths our speed and makes it easier at the beginning when it's hard and later on when it's hard. More on that later. Okay. Elm is completely different from JavaScript because JavaScript is all single-threaded and imperative. Do this, do this, do this. And Elm, don't worry about the threads. It's just asynchronous. It can happen in any order. It's not concurrent because in the end there's a single thread behind it, but it is asynchronous. You don't know what order messages will come in. But it's fully event-driven. The only thing you can do is respond to a message. And now working in Ruby, especially, don't do this in Ruby, or in Scala, or in Java, I found asynchronous programming really hard. Java Swing apps, the clients, oh, those were awful to write because you constantly had to think about threads and whose toes you were stepping on. But in Elm, you can't step on anybody's toes because everything is immutable. All your functions are data in, data out, and you just can't get in anybody's way. There's freedom in that. There's freedom especially from runtime errors. So Elm is full of compile errors, but you can't get runtime errors. I'm not talking about bugs. You can still specify that you want to do the wrong thing, but you can't get undefined is not a function. You can't get property blah blah does not exist on null. I'm like, I know JavaScript. I know undefined is not a function. Tell me something useful. This stuff is just a nightmare. And it's a nightmare that doesn't happen on Elm Street. So Elm is like, compile time errors are your friend. And I mean, if you've ever programmed Haskell, you're like, ooh, I mean, I haven't I haven't made friends with Haskell. So I haven't made, or Clojure even, well, shoot, Clojure there in the runtime, but they're still totally cryptic. What was that? You disagree? Oh, with Clojure? Oh no, you've got a Haskell shirt. Like I said, I haven't made friends with Haskell. So I have objections to the word easy because easy is very contextual, right? It depends what you know. Okay, it's simple. There you go. It's simple. And once you understand it, then it can become easy. And Elm is very specifically targeted at the general population. It's targeted at JavaScript developers and, Java, and just at everybody who is programmers mostly, but it doesn't want to require you to have a specific knowledge. Unlike there's a lot of libraries in Scala where you're like, what does this even mean? And they're like, just learn Haskell and it'll be obvious. Okay, that's like the opposite of Elm. Elm is like, it doesn't want you to have to know JavaScript. Thank goodness. It doesn't want you to have to know Haskell or any of the other languages that it draws from, because it wants to guide you along the way. So if you get a compile error in Elm and you don't know what to do, you don't have to feel stupid. That is a bug in the language, because the compiler is there to guide you step by step into figuring out the right thing. So yes, I get lots and lots of compile errors in Elm, but everyone tells me where to look and gives me as much information as it can, and when it can't give me much information, it apologizes. So my favorite thing about this particular demo is the more mistakes I make and the more compile errors I get, the better, because it shows how useful they are. All right. I think this is the slide for doing some code. Exit. There we go. Oh, no, this is not the slide for doing some code. This is the slide for, it's rude to do some code if I don't show you the syntax first. So really, really quickly, in like 4 slides, all the syntax you need to know in Elm. You can declare a name with name equals whatever, there's a literal string, or I could do a list. Lists have square brackets, list literals have square brackets, and the elements are separated by commas. You can optionally declare the type of everything. Elm encourages you to declare types, but it will do type inference, so you don't have to. If you do, oh yes, question. Do I mean pattern match or declare? In this case, I'm declaring the type like I'm saying this symbol named hello, it has a type of string. If it doesn't have a type of string, I'm going to get a compile error. I'm going to find out. Question? Okay. Right, so the nice thing about declaring your types is that the compiler can be even more specific about exactly where your problem is. Not where the heck did you pass null into something that doesn't have that property, like JavaScript. Okay. Words here is a list of string. So list is the type and string is the type parameter. Elm does have type parameters. It does not have higher-kinded types because it's balancing power against pain. It very carefully chooses language features that give you enough power to do what you want without being hard to understand and without being hard for the compiler to generate decent errors. That's actually a consideration. So string is the type parameter of list. A list is always of some type, in this case strings, and you can only put those in it. You can't declare a list of any or a list of object because that's not a thing. There's no polymorphism, there's no inheritance, there's no type hierarchy. We'll see how to put disparate objects in a list in a minute. But okay, function definition, you can define, this is function application. Main here is defined as call the function html.text, which is the text function in the HTML module, and pass it the string hello world. And main here has the type of HTML never. So it's producing HTML, which is like your virtual DOM specification. This is what I want the page to look like. And the type parameter for HTML says what kind of data can come back when the user interacts with that page. And this is a string. The user's not going to interact with it in a way that we could get data back from. So we use the never type, which has no instances. All right, so main is HTML never. Here's that text function. So I didn't mess with the body, but to declare a function, you get the function name, space, some parameters. You can do decomposition in the parameters, but usually you just give them names. And then the function type is kind of interesting because text has the type of string to HTML of something. The lowercase message type parameter here indicates, I don't care what type parameter you want. It could be anything. You can pick. But the point is, it's from string to an HTML message. If you have a function of more parameters, then the type declaration is more fun. So if you were going to construct a string by repeating another string, you might accept a string in an integer, and the type looks like this. It says, repeat, give me a string, and I'll give you something that if you give it an int, will give you another string. The return type is the last thing. And you'd say that functions in Elm are curried, as in I can pass, it's a functional language, so I can pass repeat around as like a parameter or whatever. I can pass the function. I can also give it one argument of string, and the result is another function, and I can pass that around too. This is fine. So you can do partial application. And then we will see how to define new types. Hold on, just one, there we go. There's two ways to make your own types in Elm. All you can pretty much do in your modules is declare functions and declare types. Functions are constants. And the easiest way is to just give an alias, give a name to another type. So here you have a record type. And the record is kind of like a JavaScript object, except a lot more specific, because it guarantees you can't use a property that it isn't certain is there. So this record has a URL that is a string, and I can instantiate one of those with the equal sign, URL equals cat.gif. And unfortunately, this is as close as I get to cat gifs in this presentation. And there's another way to create types, which is more entertaining. This is a union type. Just one. This is a union type. So here, it's almost like I'm creating a hierarchy, except it can have exactly only one level. I'm defining a message as an alternative. This is an algebraic data type. It's basically an OR. A message is either no-op, which is a constant, it doesn't carry any data with it, or it's button pushed. Hey, a button was pushed, but you get no other information, just button pushed. That's a thing, it's an event. Or I could have a got input event, and that has a string associated with it, like wrapped up in it. So effectively, this creates three constructors. Well, no-op and button pushed are constants, so they don't need to be functions, but got input becomes a constructor function that produces a message with a string wrapped up in it. And I could wrap up a string and an int, and I can wrap up other things in other alternatives here if I want to. To instantiate one of these, I can get a message by wrapping a string in the got input constructor. So this is how we create messages in Elm. And I'm going to sneeze. I hope. All right. To get that string out of there, I do pattern matching. So the update function is typically in Elm where we get the data in of what the user did. We also get the previous application state, and we output the next application state. And we do that by pattern matching on the message, and dang it, I'm going to sneeze, I hope. The pattern match on the message, and actually there's an alternative for button pushed too. It's just off the screen, or this wouldn't compile, because Elm will make certain that every time you break apart a message, you handle every possible case. Right, and then in the got input, we pull out the string, we get the string, I called it S here, and then the got input case is producing a record that starts with the existing model and changes it such that URL is the new string. By changes it, I don't mean like updates it, I mean copy on modify. It's entirely immutable, so we're returning a new model with the URL modified. And that's pretty much it. There's a few more things we'll see as we go along, but not much. So one thing you can do when you get started with Elm is if you just we could start with an empty directory, and we could open main.elm, so make a .elm file. The simplest way to get started, you do have to type module and then the name of the module, which usually matches the file name. Exposing, and you have to tell it. Elm very much favors explicitness, so I could say I'm exposing all the functions and types declared in this module, or I could say I'm exposing the main function. We like to be very explicit about that. I like that. So if I just wanted to make hello world, I could try, let's make main be hello world. My editor here is telling me that's not going to compile. I know, but let's see how. And then with the simplest way to get from there to a web page I can open in the browser is Elm make. Okay, prerequisite, brew install Elm. That's about it. Okay, so here's something I like about Elm. It's very polite. It doesn't want to have side effects of downloading a bunch of stuff until you're ready and sure you want to do that. So it goes and it figures out what it needs, and it says, hey, is it okay if I download this stuff? I need Elm core and HTML and virtual DOM. So the good news is it's all polite and downloads the stuff. The bad news is it doesn't cache them. So it's a good thing I have internet. Okay, here's our first compile error. Bad main type, bad. Here, it says that, yeah, this isn't good, and it also says what it needs. So if nothing else, even if I don't know how to do this, I at least have something to Google. This is meaningful. And it says, you gave me a string, I want one of these things. Okay, awesome. I'm just trying to make a static page, which is the simplest kind of Elm program to start from the beginning. So what I actually want is main to be an HTML. And we talked about the type parameter, so it'll be an HTML if never. And then to get at that, to get a string into an HTML, I'll do this. And then I have to be explicit about my imports. I'm bringing in the HTML type, but the text function I'll reference with the package modifier. Okay, there. That should compile. And it does. And then we could open target or index.html, and we would see hello world. Very exciting. Now, to do that, Elm took the shortest path to a web page. So when I ran it, it created Elm package.json, which defines the dependencies. It has like Elm package. It says, okay, we're depending on core this version and HTML this version. And it gives version ranges. So unlike package.json, Elm has its own little version schemey thing here where there's always a version range. And when I specify core 5.1.1, I can say that I will use anything up to 6. And that's okay. I can be completely certain that I can use anything up to 6, not just in the built-in libraries, but in any library published in the Elm Package Manager, because Elm enforces semantic versioning. So anyone who publishes a library, you have to start with 1.0.0. There's no 0 dot anything, hello closure. You have to make a commitment when you publish something to the Elm package repo. You're making a commitment to your users. And Elm cares more about the users of a library than it does about the creators of the library, because there are more of them. Elm is very egalitarian. And if I add a function to that library, I will be forced to at least do a minor version increment. I can't add a function and call it a patch. That last number is only for implementation changes that don't show in the interface at all. And if I delete a function or change the type of a published function, I will be forced to increment the major version, or it will not let me publish the thing because it's checking the types. Now I could be sneaky and like change the semantics and basically introduce a bug, but it will compile. My code will compile with anything below the next major version increment for sure. So that's fun. That's different about Elm and its ecosystem, because Elm is a whole programming system, unlike something like CoffeeScript that just compiles to JavaScript and then you do everything in the JavaScript ecosystem. In fact, most of the JavaScript transpilers, you wind up with all the JavaScript build tools, and with Elm you don't, which makes it a lot more approachable for someone who doesn't do front end. Okay. So that's the Elm package. You do put that in version control. Elm stuff is like all the compile output and the downloaded packages. You do not put that in version control. And then index.html is actually the output that it produced. which I don't actually want it to make me an index.html. In any real project, I want it to make me a JavaScript file, and I will write my own index.html thank you, and I can bring in that JavaScript, and I can provide my own CSS, and I can give it a title of my choice and stuff like that. So before we do anything interesting, I'm going to go ahead and run my generator. Okay, I'm going to use Rug, which is a program we're going to see rather a lot of today because it makes demos so much faster. And I'm going to generate a new Elm static page. Oh, it's going to be called Apple. I didn't want to call it Apple. Let's call it Ordina. All right, it's going to generate a new static page in a directory here and make an initial commit. And when it generates that static page, it basically copies my little Elm seed, but changes some names to match the program name that I gave it. So it's copy, paste, modify, automated, so that I can't screw up the modify, which I'm really good at. Great, so it gave me all these files. The important ones that I care about are the source directory. Should be able to tree here. Yeah, now my main.elm is in a source, and that's specified in my package.json, and I have an index.html and a styles.css to start with, and I have a build script. So Elm make only does the compile. There's separately, I need to like install packages and stuff. So yeah, clean, package install, copy the resources into target, compile. Little stuff that I forget, and now I don't have to remember it. Okay, so now we're ready for a real project. Oh, and I haven't told you yet what actually got me like started writing an Elm app in the first place, other than that Richard said it was really cool, which it is. And that is, I had an actual need for like a program with a visual interface that I couldn't write, and I just can't stand JavaScript, and undefined is not a function. So what I want is a diagramming tool, right? I want to make a diagram, and I want to put labels on it. And then I want to be able to zoom in and put more labels on it. And then I want to zoom in and put more labels and maybe link to the other parts or link outside. And this is because a year ago I was working at Stripe. Stripe is awesome, highly recommend. And I was in infrastructure, and Stripe has been around for like 6 years now, and the infrastructure is deep. It's deep, yeah. And every bit of it is a little different. And I have never found a program that will let me diagram something to increasing level of details enough to explain the infrastructure at Stripe. Adamus is still young, so we don't have that much gnarliness yet. We'll get there. Prezi is the closest, but Prezi doesn't do it. So okay, I want to make this diagramming tool. Well, today we can get as far as putting up a diagram and adding some labels to it. And that'll be fun. So let's start with a diagram. Main.elm. Okay, most of the functions that produce HTML in Elm are, they have two arguments. One is a list of attributes, and one is a list of children. So we start out with a div, but I actually want like a main. The main element has an underscore because main is a keyword in Elm. And I want a child that is a canvas, and I want it to have an attribute of style. I want it to have some style attributes, which accepts a list of tuples of string to string. So I need two strings in this tuple. Background, there's a piece of syntax I didn't put in the slides. Tuple is in parentheses, and the elements are separated by commas. Background image, comma, URL, plus, and then we want some sort of diagram. And yeah, that'll work. I'll define diagram up here to be Elm view.ping. That's our architecture diagram. Okay, when I hit save here, Elm format engages and reformats my code. So one thing I love about the Elm programming system is Elm format is a tool that everybody uses, and it says thou shalt not argue about spacing and indentation and line breaks. I mean, Elm is white space sensitive, so tabs are a syntax error. We've got that out of the way. But you're also not going to argue over, oh, is this too much vertical space? No, it's not too much vertical space. You know what? We work and we have a lot of memory in our program, in our computers these days. I've got 8 gigs free right now. Vertical space is free. And Elm also doesn't value terseness over clarity. It's very much about let's keep things organized. And yes, you might have to scroll more in order to read, but everything's going to be very carefully laid out. And yeah, doesn't skimp on space, especially vertical space. Okay, besides which, I mean, you all have monitors this big these days, right? Mine just died. That's the problem. Anyway, right, so we want this to work. We want to show this image, but I better copy the images in. Okay, so I copied in some images and some resources. Get add dot. Great. So I copied some images and some, oh, and I totally cheated by copying in CSS. So the one thing, I don't have to know about Gulp or Grunt or Mocha or Jasmine or React or Angular or any of these things, but I do have to know about HTML, and HTML I'm okay with, and CSS. So I totally got some help with this one, but actually it's funny, Elm started out originally as a language that was going, the name Elm comes from element, and you were supposed to specify elements in left and right, and this one's on top of that one and under this one. And then Evan discovered that people didn't actually want a whole new way to specify how things work and test it in every browser. They just want to output HTML and CSS because that is the standard, like it or not. And so he changed the language. And now it outputs HTML, and you can write your own CSS, or there's Elm modules to make CSS more type safe. Not today, but they exist. Okay, so we should be able to Elm make this, /build. We'll run the build script, and it'll download this again because I'm in a different directory. And okay, now we can't find attributes.style. Okay, I get tired of this compile error, so I automated it. The compile output is sufficiently like friendly and specific and nice that I actually can like pipe the output of the build into a little sed script, which then runs one of my little rug programs that edits code, and then we have that import. Yes, there it is. It's a simple program, but it's a program that edits my program. And now when we run it, we're going to get my favorite compiler. Actually, that's a lie. It's my second favorite compiler, because if you get a circular dependency in Elm, that's not allowed, and the compiler has ASCII art. It's awesome. But this is my second favorite compiler because, like 2 years ago, I was working with Elm, and when I only use it in my spare time, right, because I'm a back-end developer, and every time I would try to do this, I try to add 2 strings, and it's like, that's not a number, and I'm like, oh, I didn't want a number. How do I do string concatenation again? So I'd have to look it up because it had been a week. And so I submitted an issue to the repository that Evan created specifically to request input on, hey, if you get a compiler that is confusing to you, tell me how I could make it better. And I'm like, I'm tired of this one. And he was like, ooh, you're right. That's a really common error. And so he made a special case in the compiler so that it prints out, oh, you know, you probably wanted ++ to append strings. I'm like, oh, thank you. You saved me from having to look that up yet again. And I saved thousands of people from having to look that up. Evan is like all full of compromise if it's going to help people. A lot of people. So he tends to be like slow in responding to errors because he's waiting for a lot of them to requests, because he's waiting for a lot of them to accumulate so that he can see everyone's perspective and not just the particularly vocal users. Okay, so now it might actually build. Good. And I'm going to set up a watch. I should use Elm Reactor, but it's just fine. Oh, no, not that. To watch this directory. Watch. Okay, so it should compile for me whenever I change now. And I need to find index.xml and target where it belongs. Oh, there it is. Okay, this is the architecture of our Elm application so far. We have a main function that says the DOM should look like this, please. And we have this person over here. Oh, this person over here, that's us. We're looking at it. All right, let's look at this. If you inspect it, you can see that when people wanted to just output HTML, So the output here, it directly reflects what we said, the structure of the data that we returned from main. So we returned data that said HTML.main with a child of canvas with a style of background image is this thing. And that's exactly what we get back. At No Red Ink, they found that they had designers, and people were like, well, but if you have the HTML being built in the code instead of like in a separate template files, then how are the designers going to modify it? With their keyboards? And they had no problem. Like the designers had no problem understanding the structure of the Elm code because it mirrors HTML very clearly, and it was not an issue. And the same with when they put their CSS in Elm. It's just harder to make a mistake. That's all. Okay, so very simple HTML. But now we want. Oh, let's add a label. We should add a label. I like starting with a static page as like a prototype, because you can see, okay, what's it gonna look like without worrying about any logic. And then we can gradually build up to something else. So in addition to our canvas, we want to draw some labels, and let's hard code a list of labels. It'll have one label, and let's say Codestar. And let's put it at, I don't know, 110. How about some numbers? Okay, and we can make that function. I can specify the type first. It's a list of records with these elements. I'm going to call those label. And then we're going to output an HTML that doesn't do anything. So we'll define that type. It's a record. It has text, which is a string, and x, which is an int, and y, which is an int, and I save it. And Elm format makes everything pretty. Okay, now I can define the function. Draw labels. It has a parameter which we'll call labels, and what we want is we'll stick them all in a div, but it has many children which will map over a hypothetical format label function. And list.map here is, list is a monad. This is fine. It has a map method and a flat map method, and a constructor. And Elm totally has monads, like most languages. It has list, and it has maybe, and there's some other ones. It does not have the generic monad. So you can get a chicken burrito or a pork burrito, but you can't just get a burrito with mystery stuff inside of it. And I love this balance because it's very specific. It's very explicit. There is no generic monad, and there are no type classes. So I never have to guess what this implementation of map is going to be. I can't just say map and have the compiler figure out which implementation of map goes with this list of labels. I have to say, no, use list.map. But then I don't have to figure out which one the compiler has figured out when I'm trying to follow this code. It's incredibly explicit. No polymorphism, no dynamic dispatch. Every function has exactly one implementation, and if I were in IntelliJ, I could click down into it. Right. So I love that simplicity. And then we can define that format label. Every function has exactly one expression in the body. All it does is return data. However, you can give more things names with the let expression. And I want to name format label. And then I'm going to deconstruct the parameter with record deconstruction and say, yeah, it's a record. I want these things out of it. And then I'm going to paste in the implementation so I don't mistype it. Format label, go. All right, save. Line it up. Okay, so we're specifying the position and that we hard-coded. And we should have a label. Yay, we do. Okay, so we have a label, and we show this to our people, to our customers, right? This is our first sprint. We came up with this. And we say, well, do you like it? It was a very short sprint. Shall we continue in this direction? And they say, yes. Oh, it's so lovely. I love this permanent marker font. It's amazing. I want to make my own labels. Make it so I can make a label. Okay, great. So now this mouthless user over here wants to start interacting with the screen. So we need to make this an interactive program, not just static HTML. Let's look at the architecture for that one. Elm, beginner program, save, wait for it. There it is. Okay, here's our next architecture diagram. So we have the view function is the same, the green box is the same, and it's producing the HTML, but it's now taking a parameter, which is the application state, called the model. And the model is initialized to that circle over there, and it flows into the view to produce the DOM definition, but also it flows into the update function along with messages that are coming in from the user. So any interaction that the user has comes into us as a message, and we can update the application state based on that, which in turn will cause the view to be updated. Okay, great. Yep. Let's make it do that. In order to do that, I will run another program on it. Rug edits, Jessitron, Elm rugs. So because I like to do my Elm programs gradually, beginner program, I have a program to update my program to the next stage of the program. Because the main function becomes the view function, everything else, like my little diagram constant, gets shoved in there, and then all the other boilerplate, which I copied directly out of the Elm tutorial, gets in there. All right, let's look at it now. Okay, we have a model, which is initialized to the empty record, very exciting. We have a message. We have, here's the view function, which was our main, and everything else that was in there. Our only message is no up, and it doesn't do anything. So let's add something that does anything. The first thing we want is a text input, and a text input is 5 changes in Elm. This is not about minimizing typing. So I have a program for that. We need 5 changes because when, I'm going to need to give it a name, new label. Because in Elm, when we decide we want to save the content of the text input, we can't ask the text input what's in it. That would be directly accessing the DOM, and we don't have access to that. So we have to have every piece of information we might ever need in our application state. And that means every time I type in the text input, I got to get a message, and I got to save that in my application state. So I need a new element to my state. I was close. Yes, I did mean add text input. Thank you. I need a new element in my model and in my model type. I need a new message, and I need to handle that message. And then finally, I need the piece that I'm going to put in my view that will actually produce the text input. So all of that is going to be added in one step. And I get excited about this because Elm is very explicit. It has this stuff repeated in multiple places, but code that's repeated, we're like, oh my gosh, repetition. Oh my gosh, if I need to change things together, they need to all be there in one place. Well, maybe not. Maybe where they need to be is where the reader of the code is going to need to see them, which may be multiple places. But I can abstract that outside of the code with these little programs. So let's do a diff. And we will see a new element in our model, a new type, a new initialization is right here, a new message, a function that, my program doesn't know where in my view I want this text input, so it just gives me a function, and then I can stick that in my view where I want. And then the update function is going to handle the input from the label. Great. So update function. Here's my view. Where's my view? There it is. I want the new label in the view. New label input. Give it the model. Save. And this function, it gives it an ID, and it gets the value from the model and the other stuff that I forget. Refresh. Aha. Very exciting. We have a new label input, but it's way down there. Let's move it up. I'm going to cheat and copy this. I would abstract this if I use it a third time. Where do you want to be? Be at 300, 300, I don't know. Refresh, there it is. Okay, we have a label input. Okay, now here's the exciting bit. Every time I did that, it sent a message, and here is the debugger. So Elm has this built-in debugger because I compile with the debug flag, and it puts this on every page. And in here I can see the entire application state, all one of it. I can also see every message that my program has received in order. And if I click on them, I can see the application state after that message was received. And the view updates to what it was after that message was received. So time, unlike real life and unlike concurrent threaded programming, time in Elm is very linear. Now these messages could hypothetically come in any order, especially if I was also making calls out to the server and stuff, but they come in one at a time in a very defined order, or it's defined once they get there. And I can look back in time, and I can go back here, and I can say, well, what if I type stuff in this world, and I could get to a different world, which is very cool. I love the debugger. And it's right there, and it shows me my state. Okay, it does something else cool, which I'll show later. Now we have an input label, but we can't save it because it doesn't respond to enter. On enter is another event. So the HTML.onInput thing, HTML.events.onInput is a ready-made event for me, but unfortunately on enter is not. So I'll just, every time I use it, I need to copy this function out of the tutorial, so I just automated that. Oh, and I want a new message for save label that we'll do on enter. So I have a program for that, which just sticks the onEnter function into my view section in my main.elm, and it's going to do that, and then I'm going to tell the text input that it needs to send that event, and then I can respond to it. All right, so what we have here, I don't think I committed before that, did I? No, too much information. I've got like an extra input that I need, and I've got the onEnter function somewhere. Here it is. OnEnter, tell me what message to send. Great. And then my text input, nope, not HTML, this is local. OnEnter, please send me the save label message. Oh, but actually, when you send me the save label message, I want you to also give me the label itself. So tell me what the text should be, and tell me what the X should be. How about a nice X? And tell me what the Y should be. And that is what I want to hear. And Elm tells me it doesn't compile. I can go look at that compile error. So here I've made a change. My stuff was compiling before, but I'm like, actually I want to send this into the save label. In this case, it's like, it's not a function. Well, I want it to be a function, so let's go find it. And so now I know to change it here in the message type. I want it to wrap a label, please. And then now it's my error. Whoops, that's the wrong one. There we go. Okay, so now it takes me to the next place, and I can go find the usage of it. Whee, it's red down here. Look, we got a label. So I'm going to put it in the model, labels equals this label. Here's the prepend operator, model.labels. And now, what is it angry about? I don't know. Oh, labels. Labels is not the right field, is it? Is it? Wait, oh. Not on the field name. What did I define my model as? Oh, look. You don't even have labels. Oh, that's what I forgot to do. So when I was going to do a beginner program, I'm supposed to refactor the view method, because this, now, instead of hard coding it in the view function, which is rather dreadful, we should put it in the model. We should totally put it in the model. And so we wind up with a labels field, which is list of label. I could have done this earlier. And here our labels start out as empty, comma. Thanks. That's it. Yeah, and I actually want I'll keep my hard-coded label in my list. So we'll start with that one. But now we can add to it. And now, oh, now I'm passing a list of labels. There we go. Yay, I love the compiler. And it compiled, and we can refresh it, and we can type stuff in here. Aha! And we can save the label. Okay, but it puts it all in the same spot. So our users are like, well, that's cool. I really like the formatting on the text box, which I totally got help with because that was hard. But I need to be able to choose where the label is, obviously. Well, in this architecture, you can't choose where the label is. I could make the label empty out on save. We'll get to that. So I need more architecture. The Elm architecture is basically a framework that's built into the language. And it says, thou shalt not argue over what framework you use, you shall use this one, because you physically can't use anything else. This is another way that Elm has evolved since it started. In Evan's thesis originally, Elm was about functional reactive programming, and it was about signals and being able to manipulate the signals and combine them and map them and turn them around. And that turns out to be, I mean, some people think it's really cool, but it's really complicated and it's easy to mess up. And that's not the objective of Elm. Elm is about being easy to do things right and continue to do things right. So he took those signals out of the language, totally removed this core language feature that he wrote his thesis about, because it's not what people needed. And so there's still signals in Elm, but they're under the hood, and these are the signals that you get. This is the advanced program in Elm. This is everything you need. Okay, there's one exception. You could receive initial arguments on startup. These are all the signals that go around. So everything is coming in as a message to the update function, but we have two additional sources of messages. One is subscriptions. That's this thing here, plugging into the browser, and that can pick up where the user clicks so that we can move that text box around. And the other thing is both our initialization, let's go over here, isn't it? Our initialization and our model can output commands, which are data, which represent requests to the world, which is JavaScript. And then each of those requests results in a message that comes back and goes back into the update function. So it turned out that when you could do all kinds of signal routing and moving around and combining in Elm, what people actually did and what worked and what was maintainable was this pattern of signals. So now that's the only pattern of signals, and you don't even have to think about signals, which is spectacular. It's much simpler. And it's totally the framework built in. And now, Redux picked up on the Elm architecture, and I just read about a closure implementation today. The Elm architecture really is a good idea, and it's spreading through a lot more than Elm, which is fantastic. Okay, so we should be able to, did I upgrade the program yet? Nope. Let's do that. So now we have the evolution from a beginner program to an advanced program. And I need to change, do a commit first, Jess. I need to change the type of input, because now it needs to output some commands. It's just going to output nothing, but I have to make the types line up. And I need to change the type of every clause, every match inside the update function to also output 0 or more commands to the world. Yeah, and then I also get that subscriptions option. Good. Okay, so the type of model has been updated, and all of the update clauses have been enhanced. So my subscription section and my main is different. Great. We now have an advanced program, and that's good. And now we can do stuff. Oh, the first thing I want to do is subscribe to clicks. To subscribe to clicks, we get a little bit more boilerplate. So I want to declare a subscription to clicks in my subscription section. And in order to do that, I need a message to send. Because the click comes in, it comes in as a mouse dot position, but it has to be wrapped in one of my messages that I have to declare. So there's a new message type that I have to handle in my update clause. I also need to import mouse and add a dependency to Elm package.json, which is the part I always forget whenever I try to do this by hand. And if you do Elm every day, you just kind of live and breathe this stuff. The editors aren't nearly as important. But the second time that I go through the tutorial and look up all the different things I need to do to subscribe to clicks, it's really fun to put it in code. And then I never have to look it up again. Okay, so what did we get this time? Okay, we got the mouse in Elm package.json with the cool version-y thing. And yeah, we import the mouse, and we've got an extra. Oh, and then we have a place to store the last click, so we also added a model field. And the formatting isn't perfect, but Elm Format will fix that for me right quick. And I didn't commit last time, did I? Okay, so good. But now we have last click in our model, which is lovely. There we go. Another fun thing about writing code to modify code is if it's not perfect, whatever, it's still my code. I can change it, or I can let Elm Format fix it. Okay, what do we want to do? We wanted to do something with that click. So when we get the click, that's going to be in our update function. And we're going to get the click and the position. Oh, here's the thing. So the last click field inside the model is not a mouse position, even though that's what we want to store there. It's a maybe of mouse position, because there's no such thing as null and undefined. And back in the initialization of the model, we have to be able to, or is it? There it is. There it is. We have to be able to set the last click, but we don't have a mouse position. I'm not going to set it to 0, 0. I'm going to set it to nothing. And that is explicitly, we haven't got one yet. So Elm is very big on forcing you to be asynchronous and reactive. Like in init, it's a very common thing to do here to send an HTTP request to the server to like retrieve the data that you're going to display on the page. But in the meantime, you have to say, what does the view look like before that request arrives? You can't just sit there and wait for it. You have to define something. So it forces you to think about all the asynchronous conditions. All right, so we have a last click of nothing. And here's where we deal with it. So we set it there. And now that I have that information, in my new label input, I can put it there. But I might not have one, so I have to handle the case where last click hasn't happened yet. They haven't clicked. Case last click of, it might be nothing, in which case my new label, I still have to give it some sort of HTML, but how about a nice empty div? Or it could be just, and mouse position has an X and a Y, and now X, Y, and I said, yeah, so top is Y. Elm prevents runtime errors, does not prevent bugs, because X and Y are both ints, and I get them mixed up all the time. I could like do complicated things with the type system to prevent that, but it would be hard. And Elm is not about making it hard. Okay, so now that should be in a place. I should be able to click. Okay, it's busy compiling, right? Right? Maybe there's an error. Oh, okay, right. I added a new import. So Elm says, hey, here's your new import. Here's its transitive import. I'm going to need to download both of those things. And it nicely asks for permission. Yes, go. That's his problem. Okay, yeah, that was very polite of you, Elm. Thank you. Yay, now I can click here. And now when I say view, that's the view function. Oh, man. My on enter stopped. Oh, that's weird. It was working. I'm not even getting on enter, am I? Oh, sad day. Okay, so the first rule of demos is when it doesn't work, stop. But we will give us 2 seconds to see if we can find that. That was going to be in the update. No, it was in the view because we need that new label input. Did I mess up the saving of on enter? On enter should send a save label. Is it? Oh, okay. So maybe it actually is doing it, and my problem might be that when I do save label, I didn't clear it out. So that's okay. Yeah, so it actually is putting it there. I just can't see it because it's directly behind the letters. Because it is putting it where I wanted it to be. Thank you. Okay, so when we handle save label, we also want a couple things. We want the new label to be empty, and we want the text input to go away, which we can do by setting last click to nothing. So there you go, clear out the click. And that's probably going to do it. Oh, shoot, I forgot to save my, my history. Well, that didn't work. Oh, there it is. View. Yes. Update. Yes. Subscriptions. Yes. Check this out. So I can't, I don't have like a server to save this, but I have another way of saving my little diagram here, because the debugger has an additional functionality, which is this export button. And I've got like the list of all the messages I ever sent. When I export them, it just sends those to a file because they're data. Everything is data. And what I can do is I can go make a fix to my program, or just refresh it. So I could send somebody to this page and I can like get my diagram back by importing these events, and Elm replays them all. Now that's a total cheaty way to like save my diagram, but what it's useful for is when the tester is using this program and they say, oh, this looks like crap, if I click here, it like does this weird thing. And you're like, you did what? And they're like, no, here's the file. And the file has all of their interactions and everything my program received. And so I can see what they did, and then I can replay it. I can see what the screen looked like at any point. I can make a fix and import it again and see if it's fixed. So it's like, this is reproducibility, which is beautiful for figuring out how programs work. Love that. There's one other thing wrong with this program, which is every time I bring up the text input, I have to click in it to give it attention, which is annoying. So I want it to have focus. I've tried autofocus. That only works the first time. The next time the same field comes up, it doesn't get focus. And in JavaScript all over, it's like, well, just say request.focus. Well, you can't just request focus in Elm because that's an interaction with the DOM. So I can't do that directly. I have to send a command. So now, as the last bit of this demo, we get to fill in that last bit of the architecture that we haven't seen, which is how to send a command out to JavaScript. Now, this happens to be a built-in command. I don't have to do anything custom. But I do need a function. And here we have some more boilerplate. I need a focus command here, because the focus command is going to be a piece of data that I send out from my update function after I click, I want to put the focus there. But Elm Focus forces you to respond to the possibility of failure. Anytime you send something to the outside world, that scary JavaScript world out there, it might fail. And you have to acknowledge that. So every command has like some sort of result that comes back as a message. And in this case, request focus. Okay, so it's added a function that reminds me how to do all this stuff. And here's the thing that constructs the command that I can send out. So dom.focus is a built-in function that, given a field ID, is going to give me whatever, some sort of data that I have to wrap in a task, and the task, I have to give it a handle function which says what to do with the message that comes back. And I could get a result that's either okay, now there's no data coming back with an okay, or it could be an error. And in this case, the error that it can find is a DOM not found, and then it gives me the ID. So I also have to create some sort of message. I guess I could put no op here and ignore this too. But my little editor program here creates a message so that I could choose to respond to this. It happens that I'm going to continue to ignore it, like right here. But in the meantime, now I have this request focus command, and when we click, I can say request focus instead of command.null, focus, and new label, which, because I use my editor to add my new label field, I remembered to put an ID on it that's the same as its name. That might actually work. So here goes the request focus command. And it goes into the world, and I am not having to click again. Yay! And now we have the happy person. All right, that is an Elm application. If we go back and look at the code a little bit, it's really long. How many lines do we have now? Almost 200 lines to do. And you can see in the update function, you can see exactly how many different things we do. It's not very many, really just these three, and the other two are ignored. So whatever, that's a lot of vertical space. When it comes time to modularize this program, if it gets sufficiently complicated, it's not there yet, but when it gets complicated enough that I want to break it up, the first thing I will do is break this main file into main, update, view, message, model. The sections that exist currently will break out into files that can then depend on each other, not circularly. But the next thing that I do will not be to create components out of it, because the Elm modularization story is not based on geographic area of the page. You don't say, okay, well, I've got the text input box and I've got the background, and those should each have their own little Elm architecture with their own update method, function, and their own view. You don't actually do that. And their own little application state. No, there's one application state. And it has been observed by people who've made much bigger Elm programs than I have, that if the model winds up being 30 fields, if you have 50 different messages coming in, all in one big union type, that's okay. I mean, that's like weird. I'm like, but modularity, but encapsulation, everything's update. You wind up with like little functions that get organized into files. But at the top level, you have the Elm architecture at the top level, and it does not like replicate down. It just calls through to functions. And everybody has access to the entire application state. Well, you can't modify it, so you're not going to screw anybody else up that way. You can do some encapsulation if you're tricky with it, to be unable to drill down into other people's. But as I used to work in Akka, in an actor-based system, and also back in my old GUI days where it was pub sub, I'm like, I need to pass messages over there. I need to pass a message from the input field to the background. No, I don't. I just need to call a function. And because I have the entire application state, I can just pass it over to that other component, that other file that is an area of responsibility, and it can update its bit in the application state, and I can pass it back, and the data flow continues. So modularity happens in functions, not in the Elm architecture reproduced over and over, not in components that are geographically based, but more like business domains, really, which I find fascinating. Because I really do, that extreme purity lets it break down differently. Oh, so during the break, I will run my release script and push that little app up so that it'll be there. On the negative side, well, this is my plus and minuses of Elm. Of where is the ecosystem now? It is totally production ready. It's totally lots of people have 10, 20,000 line Elm apps in production. That's not weird. The package managers, the package management is fine, but it doesn't cache. And I haven't checked lately, but the organization of the packages online is a little iffy. Test tools. So actually, the test tools are pretty good. I should up that green bar. They've gotten better. Property-based testing, which at Elm is called fuzz testing, is built in. So every function being data in, data out makes everything really easy to test. And it's built into the testing framework to be able to generate input and make sure you still get valid output, which is pretty exciting. Libraries, you do not have access to every JavaScript library in the world. I mean, people are building interfaces to them, and you can get out to JavaScript, but the boundaries are very strict, because in JavaScript, undefined is not a function, and in Elm, that's not a thing, because undefined does not exist. And finally, I want to emphasize the point that Elm is focused on beginners and maintainers, and not on experts. And by experts, I mean programming is by far the most productive when we know our tools like the back of our hand and we know the code base. Inside and out, we know the whole system, we know what affects what, probably because we wrote it and recently. That's when people are super productive, and the faster they can type and the terser the language and the more density you have in one function, hello closure, the faster you feel, and you feel like a wizard. And your coworkers who didn't write this particular code base and have tried to make changes and shot themselves in the eye, they feel like you're a wizard. Okay, Jess, do not rant about the 10x developer. That is the most productive phase of coding, but that is not where most of us spend most of our time. Most of us are like still working on our tool set because we're typically a back-end developer, but right now we're in front end, or I don't even have a usual language anymore. I just switched from Scala to Clojure to Elm to TypeScript again. And so we're not super experts in the tool set, and even more so, and much more impactfully, we're not super experts in the particular code base we're working in and all of the systems that it interacts with. Even if you are that, if you switch to something else and come back, that dissipates. And this is where people want to rewrite stuff, because it's not really that they're going to write it a whole lot better. But if they write it, it'll be in their heads, and then they'll have that power to just change things and not worry about how cryptic the error messages are because they understand them, and not worry about being able to track all of the impacts of everything because they just know it. Elm makes that incredibly explicit. What could change this field in the model? I don't know, delete it and see where the compile error is. What processes this message? The update function. What code does it call? Exactly the code that it says it's calls, because there's no polymorphism, there's no dynamic dispatch, there's no implicits, and there's no AOP. So Elm is also optimizing for the people who have to approach a code base that they're not familiar with, which is all of us after we've been away from it for even a few weeks. So Elm is about smoothing the development process. It's not about those race car right in the middle, like Ruby on Rails or any of those, or Clojure. I really feel like Clojure does the race car bit really well, where when your program is small enough to fit in your head, and it is in your head because it's your program, oh man, you feel so productive. Elm isn't about feeling productive, it's about being productive. And it's about feeling safe. So you may get a lot of compile errors. And in JavaScript, you're used to make a change, see it. In Ruby, you make a test fail, and then you make it pass, and then you make the next test fail. In Elm, you get a compile error, and then you get the next compile error, and then the next compile error. And this is great. I didn't have to write those tests. But it's safe, and the development is smoothed out, and you can make changes without a whole lot of worrying about what else you're going to impact because the compiler has your back. So yes, you get compile errors, but you don't get undefined as not a function. Okay, so here we talked about Elm with Atomist. In the next talk after the break, I'm going to show how the rug is actually written in Scala. So to edit the Elm programs, I wrote a parser in Scala because Elm, and the official implementation of the Elm language, like the specification, is the Haskell compiler. As all compilers should be. Yeah, totally. Yeah, if you're going to write a compiler, write it in Haskell. If you're going to write a parser, consider writing it in Scala. So we'll see how I did that, and also how that fits into the little editor programs, which are in TypeScript. So next, we have a 10-minute break, I think. Is it, how long? Thank you.
I would like to ask first if anyone else still has a question before we go to the break about this part yet. So
if you if you have a question that you want to have on record, then ask it now.
Yeah,
if you want a secret question, then just come up and talk
later.
to me. Is there one? What? Say that again. Oh, the rant about the 10x. You haven't even heard the rant. That was the nice rant.
Okay, thank you. Yeah, so I really liked how you put it. I hope the video will be online, so I can show the snippet to my boss, maybe, because I would never put it as nicely as you did.
Oh, cool.
But actually, I have a question about the presentation, a technical question. At some point, you implemented this on enter thing.
Yes. Yeah, totally. So the onEnter method, here's the way I originally found the onEnter method, which was by Googling it and finding it in the canonical example to do NBC app. And then I cut and pasted this. And I cut and pasted it into a program which, if I open IntelliJ, I will find it. And so because the third time I cut and pasted this, I'm like, can I just automate this cut and paste so that I don't forget bits of it, because I change a little bit of it each time. So these are my Elm rugs, and I implemented all these programs and the parser again for this presentation, because rug has changed. It's all TypeScript. All the programs are in TypeScript now. Let's see, change main. We wanted onEnter.TypeScript. So here, I plugged that program, that function in here, and I changed it. I like to be really specific about like JSON.decode, and I like to be really, I don't like to import the functions. I like to qualify them with their names each time to make it even more obvious exactly what I'm calling. Okay, so I put that in there, and then I have this editor that, did you want to see the onEnter function itself? Both, okay. I'll switch over to the syntax highlighting to say what onEnter does, because it is really confusing. But this program says, add the import for JSON.decode, add the import for HTML.events if it's not there already, and then add this function of that code to the view section. And then if I passed in a message as a parameter, add a message so that I can pass it on onEnter. And this is TypeScript stuff that is kind of interesting. But we'll see more of that in the next presentation maybe. And then the onEnter function itself, where'd it go? Come back onEnter. Yep, you. There we go. All right. So what we're actually subscribing to is this on, the generic on event, and then we specify that we want the key down events. And when we ask for key down events, what we get is a key code, which is JSON data. So when you get data from the outside world, it's always JSON. Even though in this case it's a flippin' number, it's still a JSON number. It's not an Elm number. So there's no guarantee that the type is correct. So we have to decode the JSON with this one. So this html.events.keycode, I believe, provides a decoder that turns that thing into a number, and then we apply this isEnter function to it. No, I don't know what that does. It converts the key code into something. I'd have to look it up. But this one says, oh yeah, it is converting it into an Elm number, so that our isEnter can then say, if that's a 13, then the outcome of our JSON decoding is success, and the message that we passed in. Success, send this message. Otherwise, it's this decode fail thing, and I don't know how that works. Yeah. Does anybody have more familiar with the, we're getting a success or a failure here. Stops the propagation of the event. Oh, nice. I was wondering if you could do that. Okay, good. So if we fail, nothing happens, but if we succeed, then we're going to get this message back, which is the one that I passed in, which winds up being the save label.
Time for other questions because your ice cream is melting.
Ooh.
So 10-minute break. Thank you. Thank you.